All right, so here is how you do long division of polynomials. This is this fourth degree polynomial divided by the second degree polynomial. So here we go. This is the divisor x squared minus 2x plus 3 into the dividend x to the fourth plus 3x squared plus 1. Now when you're writing this part of it, sometimes it's useful to save these spaces, any power of x that's not there with zeros. It's not always necessary. You don't have to, but it keeps your work organized. And then you can it's easier to line up like terms. So that's what I'm going to do. So first thing you have to do is figure out how many times this goes into this. So basically, you're gonna write a term up here so that when you multiply it by x squared, it's going to exactly equal this first term. So you're going to pick a term up here. When multiplied by this first term would equal exactly this term, because the point is we're going to subtract that out. So if you multiply x squared times x squared, you'll get x to the fourth. So that's where we begin. Now you multiply x squared by this whole divisor. So x squared times x squared is x to the fourth, and I'm going to distribute. X squared times a negative 2x is negative 2x cubed. So this was the advantage right here of writing that 0x cubed, because now you have a like term to line it under. And then plus 3x squared. Now you're going to subtract these, just like regular long division. What a lot of people like to do is just add the opposite instead. It makes for fewer dumb mistakes. So I'm going to add the opposite, meaning I'm going to change all my signs. So negative, positive, negative, and just add. So same thing as subtraction. 0x cubed plus 2x cubed is 2x cubed. 3x squared plus negative 3x squared is 0x squared. So I'm going to save that space and then bring down everything else. So now I start the whole thing all over again. It's really easy. Now you just do the same thing. But now you're going to try to figure out what you have to multiply x squared by to get this number, and then repeat. So since I need to get this to be 2x cubed, I have to multiply the x squared by 2x. So plus 2x. Be aware of your signs. If that was negative 2x cubed, you'd have to use a negative. So now I'm going to distribute again. So 2x squared times x squared is 2x cubed. That's what I needed. And then whatever else happens, happens. So 2x times a negative 2x is a negative 4x squared. I had that 0x squared to line it up under. And 2x times 3 is 6x. And then I'm going to subtract again. And I'm going to add the opposite again instead of subtracting. So make this negative, make this positive, and make this negative. So now I add. 2x cubed minus 2x cubed is 0. That's the whole point. 0x squared plus 4x squared is 4x squared. 0x plus a negative 6x is a negative 6x. Bring down the 1. Now, you keep going until you're done. So how do you tell when you're done? This degree down here, too, has to be lower than this degree up here with your divisor, which is 2. So it's not lower yet, so I have one more step to do. So I have to figure out the same thing. What do I have to multiply x squared by to get 4x squared? And the answer is a positive 4. So this is going to be the last time I'm doing this. Distribute the 4, 4x squared minus 8x plus 12, subtract or add the opposites. So I get negative 6x plus 8x is 2x. 1 plus a negative 12 is a negative 11. So that's the remainder. The degree is 1, and it's less than this degree of 2. So the final solution here, the final answer is just like in regular arithmetic, you do the quotient, which is this, plus the remainder over the divisor. So it would be, the quotient is x squared plus 2x plus 4 plus your remainder, 2x minus 11, over your divisor, which is x squared minus 2x plus 3. Now, that's exactly what this equals. So if you took a graphic calculator and you typed in y equals this, and this, you're going to get the exact same thing. So that's a good check for you. That is all.